Today we are going to learn on how we can be able to name organic compounds, as you can see here on the board. I am going to make it so simplified that even though you don't have any understanding when it comes to organic chemistry, after watching this video you are going to be a pro when it comes to organic compound nomenclature. So let's start with the first one here on the board before we move into details on the step-by-step ways in which you can use to name organic compound. Now this is a compound here on the board. We have CH3 minus CH open bracket OH bracket close and slash CH3. To name this compound, the first thing you have to do is to check how many carbon compounds are here. So we have 3 carbon, right? So this is what 3 carbon, and you can also represent this structure in what a skeletal form. So this is what 3 carbon structure, and this is a 3 carbon structure. This particular carbon is bounded by 3 hydrogen atoms. So bounded by 3 hydrogen atoms. The second carbon has what? A OH, and it's also bounded by 1 hydrogen atom. So we have 1 hydrogen atom and we have what? OH. And the last carbon is bounded by 3 hydrogen what? Atom, right? Is bounded by 3 hydrogen atom. Looking at this structure on the board, we get to find out that the OH is found in carbon number what? 2. It is found in what? Carbon number 2. So if you want to name this compound, the name of this compound is what? Propan 2 what? All. It is propan 2 all because of the functional group OH, which is what? Alcohol, which is represented as what? The OL. Hello and welcome to my YouTube channel. My name is Basi Ejoba, and in my channel, I help students level up their academic game. So if you want to level up your academic game as a student, please subscribe to my YouTube channel, and also don't forget to share my videos to your friends so that they can come here and get value, and in turn I'll feel motivated to continue dropping helpful videos like this. So if you are preparing for your JAMB UTME, you are preparing for your WAEC, you are preparing for your NECO GCE, or even your school examination, then make sure you subscribe to my YouTube channel, because I promise to bring you helpful videos based on chemistry and also in biology. And today we are going to be learning on how we can be able to name organic compounds. When it comes to organic chemistry, a lot of students are deficient in this particular aspect because their secondary school teachers are shying away from it. Most of the time, maybe they are not grounded in it, or because of the heavy workloads that is based on organic chemistry as a whole, they tend to run away from it. But these students meet these questions in the exam hall, especially when it comes to WAEC and JAMB, and it gets the students stranded. That is why in this video, we are going to be breaking everything when it comes to how you can be able to name organic compounds. And today, we are going to first of all start with the name, the general name of how we can be able to name what? Organic compounds. Before time, there used to be issues when it comes to naming of organic compounds until a group of scientists came out and gave this acronym, which is known as IUPAC. They came out and gave this acronym, which is known as what? IUPAC. IUPAC, which is IUPAC, stands for what? International. This is International Union. This is International Union of Pure and Applied Chemistry. So IUPAC simply stands for what? International Union of Pure and Applied what? Chemistry. What is IUPAC nomenclature? IUPAC nomenclature came out so that any organic molecule, anywhere, anyone can be able to identify it from the name what? Alone. So that when you see what? An organic molecule, anywhere you are, anytime you can be able to what identify that what molecule just by looking at the what name. So like I said, I'm going to be teaching you how you can be able to name this what organic what compounds. And basically, when it comes to naming of organic compounds, you need three key parts to be able to name organic compounds. You need, first of all, the prefix, the parent name, and the word suffix. So let's see how you can be able to get this. I will be drawing a table so that you can be able to get these word names on how they would come what about, right? So you can be able to get these names and how they come to be. So let's draw our table and say the three key parts, right? The three key parts, you need to know this if you want to be able to name organic compounds or if you want to excel in organic chemistry. So we say the part, we draw our line, and we say the meaning of the part, and we give you what? An example. We give you example. So the first part you need is the word prefix. Prefix from English means what? Before, right? So we say prefix. That is the first part that you would need. Now, what is the meaning of prefix in organic chemistry? Prefix simply means the position or side group attached to the main carbon chain. So we say a position or a side group, position or sides group, a position or what? A side group attached what? To the main chain. Attached to the main what? Chain. A prefix is a position or side group attached to the what? Main chain. Example is something like methyl, something like chloro, something like what? 2 or 3 or 4. You understand? You call it before you call the parent what? Chain. The second there is the parent name, which is the parent chain. So we have the parents, we have the parent name. And for the parent name is simply what? The number of carbon atoms in the main chain. So we say the number of what? Carbon atoms. The number of carbon atoms in the main chain. In the main chain. An example is what? For example, methyl, ethyl, propane, butane. So we say met, ethyl, propane, butane, and the rest. We are going to get there. And the last is what? The suffix. The last we have is the what? The suffix. The suffix simply means the type of what? Compound or the functional group that is found in that particular what? Name. So we say functional group. We say the functional what? Group or what? The compound that is what? Found there. An example of this functional group I gave you, it can be what? The all, it can be the what? The in, it can be the what? In, and it can be the what? Ein. Right? So this is what is needed. You have to first of all know when it comes to naming of what? Organic what? Compounds. You have to first of all know the parts. You have to first of all know the part, the meaning, and the word example. And we have just three parts. We have the prefix, the parent name, and the word suffix. We are going to be applying this thing right away because we are heading to the step-by-step method on how you can be able to name these organic compounds. So we are moving ahead to the step-by-step method. So let's talk about the step-by-step method in which we can use to name organic compounds. The first thing you have to do is to find the longest carbon chain. The longest carbon chain, right? You saw in that reaction, in that compound that I gave, in that formula that I gave you something like this, right? I gave you something like this and something like this. The first thing you have to do is to find the longest what? Carbon word chain. Now you have to understand that there are two ways you can use to represent organic compounds. There are two ways you can use to represent organic compounds, or two structures of organic compounds. The first one is what we call the what? The condensed structure, and this is example of the word condensed word structure. When you see the word carbon compounds or the molecules in the word a straight word line, this is what we call what? Condensed structure. And there's also another one which we call the word the Kekulot structure. the calculate what structure. The calculate structure is what is known as the what the skeletal what structure. This is the type of structure where we get to open this up so that it can be very easy for what naming. That is why you see me the first time I did something like this so that I can easily what name it, right? I can easily what get it. This is what OH, and this is what our H, and is bounded by what 3 hydrogen what atom, right? So this first one is what we call the condensed structure, and this is what we call, let me write it. So this is what we call condensed structure, condensed, and this is what we call the what the calculate. Any of them can be used to what represent what organic what compound names, right, in their nomenclature. So any of these structures can be what used. But now we are trying to look about how we can be able to name this what organic what compound. And I said we first of all have to look for the what the longest carbon what chain. This longest carbon chain gives you the what parent what name. This longest carbon chain gives you the what parent what name. So for you to be able to get this parent name, you are first of all supposed to get the number and the what the name. So let's do something here. Number of carbons. Let's say the number of carbons, and here we say the word the name, right? The name. Yeah, that is the name or the word the root name. Yeah, let's use the root word name. So when it is one carbon atom, so let's say we have 1, 2, 3, 4, 5, and what 6 and what 7. When it is just one carbon, it is known as what methane. When it is one carbon, it is known as what methane. When it is 2 carbon, it is known as what ethane. When it is 3 carbon, it is known as what propane. When it is 4 carbon, it is known as what butane. When it is 5 carbon, so the 5 carbon atom is pentane. 5 carbon is known as what pentane. Then the 6 carbon is known as hexane. The 7 carbon is known as what heptane. The 8 carbon atom is known as what octane. The 9 is known as what nonane, and 10 is known as what decane. So this is the first thing you're supposed to note when it comes to naming of what organic what compounds. You are supposed to first of all know the what longest what carbon chain. It is the longest carbon chain that will give us what parent what name. So the second step is the ability for you to identify the functional group, and the functional group determines the suffix ending. And what do you understand as suffix in English language is simply talking about what the ending part of a root word. So we have a root word and we have what the suffix, which is always at the word end. That's the same thing that is applying here in what organic chemistry. So you have to identify the functional group, and the functional group is always at the word end, right? So this is a table where you can be able to know the different types of what functional word group. So we have the functional group here, we have their formula, and we have their what suffixes, what you are supposed to put at the end when you see something that is related to what it, right? So we have the first one, which is what alkane. Alkane, the formula of alkane is what C/what C. This is what a single bond. This is what a single word bond. And the suffix is what ane, which is what ane, that is ane. The second one is what alkene. Alkene is represented by what C. This is a 2 carbon with what double what bond. So this is what a double bond when it comes to what alkene, right? And the suffix is what ene, that is for alkene. Then we have for alkyne, which is C with a triple bond word C, and this is what we call triple word bond. Triple word bond when it comes to what alkyne, and it is the suffix is what yne, that is what alkyne. Alkyne, yne. We also have what alcohol. Alcohol, the formula of alcohol is what the OH. The formula for alcohol is what the OH. Put your mind back when we started this class. I gave you what a structure that has the word OH, and at the end I said it is what propan 2 what all, right? I didn't say propan 2 OH. I said propan 2 all because the suffix for alcohol is the what the OL. The suffix for alcohol is what OL. We move ahead to the next one, which is what the aldehyde. The aldehyde is what CHO. The formula for the aldehyde is what CHO, and the suffix for the aldehyde is what AL. So you can get to see something like propan 2R, propan 2-nal, or propan 2-nal. You understand? Propan 2R at the end. So that means there's a presence of what the CHO. Right? We have the next one, which is what the carboxylic acid. The carboxylic acid, the formula for carboxylic acid is the what COOH. That is the formula for the carboxylic acid, and the suffix for the carboxylic acid is what the oic acid. That is the OIC acid. That means if we are to name it, for example, we are going to say what propantenoic acid, propantenoic acid, or the propanoic what acid. Propanal. Arabin is for aldehyde, we have said propanal, but since it's for carboxylic acid, we say what propanoic what acid. So this is what you are supposed to understand as the what second step by identifying the what functional what group. Step number 3 is number the carbon chain. So this is the carbon chain. This is what we mean by the word carbon what chain. And there is no rule that states that the carbon chain must be what straight. So we have what straight carbon chains, and we have what branch what carbon what chains, right? So these carbon chains must not be necessarily what straight, right? So now, why you number the carbon chain is that number, or how you can be able to get this is that you number from the end nearest to the word functional group or what branch. So let's assume this is what our carbon chain. So this, let's assume this is our carbon chain. This is 1, 2, 3, 4. This is 4 carbon atom. 4 carbon atom is for butane. So the first thing you do is to write your butane somewhere. So you write here your butane somewhere, right? So this is your butane, and you say you number from the end nearest to the functional group. So this is bounded by an hydrogen atom or by hydrogen atoms, and this is what the OH, and this is our H, this is our H, and this is our H, bounded by what 3H, right? So this is known as what butanol. This is known as what? Now, okay, let me show you something. Let me show you something now. This is 1, 2, 3, 4. We said you number from the end nearest to the functional group or the what? The branch. You number from the end that is nearest to the what? Functional group. So if we want to start numbering, we are not going to start our numbering here. We are not going to start our numbering. We are not going to say 1, 2, 3, what? 4. This is what a wrong way of what numbering what carbon what chains. What you simply do is that you give the shortest number. You give the shortest number to where you find the functional what group. So at this point in time, instead of saying 1, 2, 3, 4, we rather start with here and we say 1, 2, 3, 4. Giving the functional group the least possible what number, which is what number 2. So if we want to name this right now, we say this is going to be what but, using the parent name, but what butan 2 all, butan 2 what all. So this is what butan 2 what all, butan carbon number 2 and the word all, because it is at carbon number 2 we find the word the functional word group. Let's assume this thing is changed. Let's assume we change this word functional group from this particular position. So let's say we change the functional group from this particular position, right, to this particular word position. What is still going to happen is that you start accounting, or you start accounting where you can give the functional group the least possible number. So we are going to start our counting here 1, 2, 3, what 4, right? And the name is going to be what butan 2 what all. Or also talking about the double bonds, we talked about the single bond, the double bond, and the what triple what bond. So let's say we have something like this. Let's say we have something like this, right? Let's say this is what we have. Let's say this is what we have, right? This is our H, and this is our H, right? So let's say this is what we have. This is, sorry, this is our what? Our H, and here is our what? H, our H, and our what? H, right? So let's assume this is what we have. This is known as what? Butene. This is known as what? The butene. This is known as butene. Why is it butene? It's because when you want to start counting, we say 1, 2, 3, and what? 4. The double bond is found at carbon number 2. The double bond is found at carbon what? Number 2. So we give the name in reference to the carbon what chain where the functional group is being found, right? So at this particular point, the functional group is found at what? Carbon number 2, and the name is going to be what? Butene. So it says the number from the end that is nearest to the functional group or the branch, giving the functional group the least possible number, and the number is what is going to show where the group is attached. At this point in time, even though you just give me the name butene and you say I should represent it structurally, this is what I will be giving to you, because the name here butene has already told me where I am going to find the functional group, which is the alkene in carbon number 2. So this is the step number 3. So the next step, which is step number 4, is identify and name the side group. The side group there is the substituent. The side group there is the substituent. And the side group, remember when I gave you the 3 key parts, the side group is what we call the prefix. That means they come before the parent's name. So the side group here is the prefix, and they are known as the substituent. So let's get something. It says if other groups like CH3, Cl are attached, name them as what? Prefix. Remember, I just talk about prefix right now, right? I says CH3. CH3 here is simply what? Methyl. Cl, which is what? Chlorine, but we call it the chloro, are attached, name them as what? Prefix. So these are some of the substituents we have here, or which you can call the site name, or you can call the prefixes that we have here. We have the first one, which is what? CH3. CH3, the prefix for CH3 is what? Methyl. CH3 is what? Methyl. C2H5 is what? Ethyl. Bro is what? Bromo. And Cl is what? Chloro. Right? So we have CH3 methyl, C2H5 as ethyl, Bro as bromo, Cl as chloro, and a lot of them. So let's have a very simple example. Let's say we have something like 2-methylpropane. I hope you can see the board. Let's say we have something like 2-methylpropane, right? So this is 2-methylpropane. They say represent this. To write this structure is very, very simple. This is methyl. Methyl is CH3. So what is going to happen here is that propane is a 3-carbon atom. Propane is a 3-carbon atom. So first of all, represent your carbon atom. And remember when I say these chains can be a straight chain, or it can be a branch or chain. So we say 1, 2, and 3. This is, we have represented our carbon atom, and they are being bounded by hydrogen. They are being bounded by hydrogen. Now note 2-methylpropane. What this is simply about is that this is a 3-carbon atom with methyl found in carbon number 2. With methyl found in carbon number 2. So at this point in time, for we to be able to represent this methyl, what we simply have to do here is our H. What we simply have to do is we come down here, and our C, methyl is a C with 3 H, right? So this is our methyl, and here is bounded by 3 hydrogen atom. Here is bounded by 3 hydrogen atom. So this is 2-methylpropane. Let me do this so you can easily see it. This is 2-methylpropane, right? So this is 2-methylpropane. This is 2-methylpropane. This is carbon number. If you want to count it, this is carbon number 1, 2, 3. If you want to still go this way, this is the carbon number 1, 2, or 3. So this is a 3-carbon atom with methyl found in carbon number 2. So this is how you can be able to name the site name. And they always come, because they are prefixes, they always come before the parent name. This is methyl This is 2-methylpropane coming before the word parent word name, right? So this is how we get it. Now, if there's also a presence of what a functional word group, this can also be what 2-methyl propanol. This can also be known as what, for example, 2-methyl propanol. If it is to be 2-methylpropanol, at this point in time, the word carbon number one, the carbon number one here, for example, is going to what, change to what, the word OH. It's going to change to what, the OH, which is what, alcohol. So at this point in time, the name has automatically changed from 2-methylpropane to what, 2-methylpropanol. So this is what step number 4 on how you can be able to name what organic what compound. Step number 5, which is the last step on the list, is you have to combine everything that we have done in step number 1, step number 2, step number 3, and step number 4. Now step number 5 is that you combine what every word thing. And note, for you to get a perfect organic nomenclature, organic compound nomenclature, or a organic compound name, is that you have to first of all get the prefix, get the parent, plus the suffix, which will give you what a perfect word name. So there's a prefix, there's a parent, there's a suffix, and that is how you get what a parent's name. And we have some examples here on the board. I'm going to do this first. I'm going to do this 1 and this 2, then you do number 3, and make sure you drop it in the comment section. So you are going to name the last compound here on the list for me. So we have CH3, CH2, and what CH3. For me, one of the best way I can be easily able to name this compound is that I have to break them down. I have to open them in a skeletal structure, which I say the skeletal structure is the Kekule structure. So for we to get this, I simply represent it by saying, for we to get this, I say we have our first carbon, our second carbon, and we have our third carbon, bounded by 3 hydrogen atoms, and this one bounded by 2, and this bounded by 3 hydrogen atoms, right? So to get this is simply carbon number 1, 2, 3. This is 3 carbon atom, and this is what propane. This is simply what propane. This is simply what propane, right? So carbon number 2, same thing. Compound number 2 is same thing. We say this is CH2. So we simply say for compound number 2. So let's clean this. Let's see how we can be able to clean this. And we say we have our C. We have bounded by 2 hydrogen. We have carbon bounded by 2 hydrogen. We have the presence of our double bond, and here is bounded by 1 hydrogen, and our carbon, which is bounded by 3 hydrogen atoms, right? So this is another sorry, we have our CH2. Okay, this is our CH2, right? So this is another perfect name. Look at it. We have 3 carbon atom. We have 1, 2, 3, right? So we have carbon 1, 2, 3, and the double bond is found at carbon number 2. The double bond is found at carbon number 2, and we say the double bond is represented as EAE. So the name of this is simply we can simply say pro 2 in. We can say pro 2 in. 1, 2, 3. That is pro 2 in. That is the name of this carbon compound, right? So you will do the last one for me and drop it in the comment section. Tell me the name of this compound and drop it in the comment section. So this is how you can be able to name organic compounds. This is one of the most simplified way which I believe you can use to name organic compound. And if you find this video helpful, please make sure you hit on the red subscribe button. If you know that you have learned something, feel free to share these videos to your friends so that they can come here and get value. Check out all my videos. I've been able to simplify chemistry and biology to the least basics. Please, like I said, do this assignment, drop it in the comment section. And if you want to be part of us, if you want to join my private WhatsApp group, make sure you request my number in the comment section. I will drop my number, chat me on WhatsApp, and you'll be added to our WhatsApp group where you get access to my tutors, physics tutors, mathematics tutors. You get access to timely clarifications if you have any. You also have access to materials, resources that are going to help you in this journey, whether you're preparing for WAEC, whether you're preparing for JAMB Chemistry, GCE, or any exam as far as you are a Nigeria student. And until I see you in my next video, always remember that you're wonderful, Always remember that you're unique, and always remember that you're a pace setter. I really love you. Thank you.